All right, what's up, guys? This is the 9.3 notes. Sorry, my nose sounds a little congested. Hopefully I don't sound too much like Squidward in this video, but we are in this packet, Unit 9. We're on page 13. We're going to do 13 through 15. All right, so today's learning target is I can use properties of inscribed angles and inscribed polygons to find missing angles and arcs. Okay. So we have talked about central angles with circles. That is an angle that is in the center of the circle. Now we're going to talk about something called inscribed angles. It's really not too crazy. Basically, an inscribed angle is formed by two chords. So here's a chord AB and the chord BC. Two chords that have a vertex on the circle. Okay, so let's talk about the difference real quick. If I go back to like 9.1, okay, this was a central angle because the vertex where the angle changes direction was the center. Okay, that's why it's called a central angle. But here, where the vertex changes direction is literally on the circle. This is called an inscribed angle. It's very important that you understand the difference there. The measure of the inscribed angle is always equal to half the measure of the intercepted arc. Blah, blah, blah. All you really need to know is this equation. The arc is going to equal 2 times the angle. So let me show you what I mean by that. The arc, this thing right here, the arc is always going to be twice as big as the angle. Here's the angle. Okay, so that angle right there. The arc is always going to be 2 times the inscribed angle. And you're like, okay, I got this. We totally got this. Let's take a look at some examples. In this first one, we're looking for the measure of angle LMK. I'm going to color it. Okay, you might have 2 highlighters out. Maybe pick a green or a arc highlighter and an angle highlighter. I'm going to do yellow as my angle highlighter. This is LMK. That's my angle. That's what I'm looking for. Okay. And this is my arc. Okay. So every single time I want you to use this equation. Arc equals 2 times angle. Arc equals 2 times the angle. Okay. Okay, what has it given us? It has given us the arc, 70 degrees. It is asking us for the angle. Okay, so if it tells us the arc is 70, how do we find the angle? Well, we divide both sides by 2. The angle is 35 degrees. Okay, 35 degrees. Guys, that's it. That's all we did. That's all you got to do. So basically, back up, all that just happened, if they give you the arc and they ask you for the inscribed angle, just divide by 2. It's not a big deal. That's all you got to do. Okay, you're going to crush it. Number 2, it's a little bit different. We can still do this. Number 2 is a little bit trickier because we got to remember some knowledge that we had from the last time. Okay, so if we're trying to find this angle, we're trying to find that angle right here with the question mark. It would probably be helpful for us to eventually know this arc, wouldn't it? Okay, because last time we used that arc to find the angle, we just divided by 2, right? But in order to figure out the angle here, we kind of need to know that arc. Well, we don't know the arc yet. Here's how we do it. This whole circle adds up to how many degrees? Think about it. Hopefully you remember that was 360. Okay, so if we know this part of the circle, the only part we're missing is this green part. So we can do 360 minus 105 minus 149. That's the rest of the circle. that's going to equal the green part. So 360 minus 105 minus 149 equals 106. So now I know this is 106. So that's my answer, right? We're done? Oh, no. So we know the green arc is 106. Okay, cool. Was that what we were asking for? No. Okay, look. So we got 106. We're looking for the angle. All right, well, this time we knew the arc. How did we find the angle? We divided by 2. Okay, we can do that again. So 106 divided by 2 is going to equal 53. So this angle is actually 53 degrees. Okay? 53 degrees. All right, what about number 3? We're finding the measure of angle DEF. Oh my goodness. So this is an arc. D to E to F. Okay, that's the arc we're trying to find. Well, conveniently enough, it's created by an angle that we do know the measure of. Okay, that angle creates the green arc. That yellow angle creates the green arc. So if we do our equation again, arc equals 2 times angle, this time we're looking for the arc. It has given us the angle, which is 104. Arc equals 2 times 104, which is, arc is going to equal 208 degrees. That's our answer. But Mr. Colston, wait up. What about all these lines? Don't they affect anything? Nah. It's like they're not even there. Let me white them out. We don't even need these lines. We don't need this line. It's just distracting us. We don't need that line at all. Those are just distracting you. Now you feel like you'd probably be able to do it because this angle creates this arc. Okay, so bottom line, if they give you the arc and you're trying to find the angle, divide by 2. All right? If they give you the angle and you're trying to find the arc, multiply by 2. All right? Hopefully you get that pattern by now. It's very critical. We're not going to do a lot of examples of that anymore. So hopefully you feel good about that. All right, now page 14, I believe. Page 14. Inscribed Polygon. Okay, now this is still not very bad. Still not bad at all. Okay. So at this one, we know that ABC is a triangle that is inscribed. There's that word again. Okay, it's inscribed because all of these points are on the circle. Okay, each vertex on the circle incides the circle's chords. Okay, so in this situation, we have a very simple rule. This angle plus this angle plus this angle is all going to equal 180 degrees. That angle plus this angle plus this angle is going to equal 180. Well, duh, Mr. Colston. That's what all triangles equal. Of course, not a big deal. Just because it's in a circle doesn't mean that the same rule doesn't apply. We're killing it. Okay, now what's this other rule? This is saying that the measure of arc BC, okay, that's one arc, cool, plus the measure of this arc, AC, okay, cool, plus the measure of this arc, AB, well, Mr. Colston, the 3 arcs, or the 3 chords, the 3 arcs you just showed me, Mr. Colston, are the only 3 arcs that make up this circle. So they have to add up to 360. That just makes sense. So this arc plus this arc plus this arc equals 360. Very simple. Very simple. Okay, so let's use that knowledge down here. It says find the measure of the arc. Remember that the diameter cuts the circle in half. The diameter cuts the circle in half. Interesting. Okay, so we might use that knowledge. Well, if you look at this circle, we do have a diameter right here, don't we? We have a diameter. Let me color it with this. We have a diameter. That's the diameter. So guys, that means that this entire half circle is equal to 180 degrees. Hopefully you remember that from last time. This half circle right here is equal to 180 degrees. That will help us later on. But before we use that information, we have to determine what we're trying to find. So we're trying to find the measure of this arc, JK. We don't have quite enough information yet. Okay? A helpful thing to do would be, notice this is an inscribed angle. This is an inscribed angle. It has given us the angle. So remember over here, if they gave us the angle, what did we do? We multiplied by 2. Gave us the angle, multiplied by 2. So if this is 50, this arc right here would be 100 degrees. Okay. Let me use my colors again. This is my angle, 50. So my arc that it creates is 100 degrees. All right. Now what do we do? Think about what you maybe do. I want to maybe take a couple minutes, take a couple seconds, think about what we might do next. Don't just wait for me to do it. If we know that this arc right here is 100, we know the entire semicircle equals 180. We could do 180 minus 100. That would be 80 degrees. So our answer is 80 degrees. So step 1, we use the fact that inscribed angle is half of the arc to get 100. And then we use the fact that this is a semicircle to get 80. Okay. All right, what about this one? Measure of the angle. So now we're looking for this angle right here. Okay. That's another inscribed angle. That might be helpful. Okay, that might be helpful later on. So let's go ahead and highlight this is my angle. Let's talk about the entire arc here. This is the entire arc. Okay. So let's talk about what this entire green part would be. Okay. Forget that there's an F here. I'm talking about RG. RG. Okay. If the entire circle is 360, this is 76, this is 96. Let's do 360 minus 76 minus 96. Let's see what we get. 360 minus 76 minus 96 is going to equal 188. So what I just found out is that R all the way to G is going to be 188 degrees. Okay, that's cool. That's good to know. Now, at this point, you should probably be able to figure out, how do we figure out what the question mark is? Okay, there's a pattern, guys. It has given us the arc. What is the inscribed angle? 188 divided by 2 equals something. 94. So this angle right here is 94 degrees. Okay, 94 degrees. All right. So guys, it's just kind of like a puzzle. You're using a lot of different skills here. Okay, what about this one? Again, we have another inscribed angle. I'm going to highlight it yellow. I'm going to highlight the arc it creates green. All right. If this angle is 100 degrees, what is the arc? Again, as a reminder, arc equals 2 times angle. Let's write that down, in fact. Arc equals 2 times the angle. Okay, so if the arc is what we're looking for, the angle is 100. 2 times 100 would equal 200. So this thing right here is 200 degrees. Okay, let's label that. 200 degrees. That whole thing is 200 degrees. All right, we're turning and burning. We're looking for the measure of this arc right here. Okay. Well, guys, we know pretty much the entire circle at this point. We know 200. We know 64. So all we got to do there is do 360. That's the entire circle. Minus this part, the green part, 200. Minus the little 64. And that should give us what we're looking for. So 360 minus 200 minus 64 is 96 degrees. That should be 96 degrees. Okay? That's page 14. Hopefully you guys are still feeling okay. Let's talk about page 15. Page 15. Okay. Okay, so page 15, it's asking us on this one to find the value of x. Oh my gosh, this is our first time we've had x today. We got this. We got a triangle, an inscribed triangle in a circle. All right, don't freak out. Let's look at the hint. It says, remember that a diameter, let's look. Do we have a diameter? Yeah, we kind of have a diameter right here. Look, here's our diameter. Okay. All right, what does a diameter do? It cuts a circle in half. Okay. All right, cool. We got this. So you're telling me that this diameter makes this thing a half. Interesting. Okay, and so this also makes this side a half. Cool. What's half of a circle? How many degrees? Well, 180. So wait, Mr. Colson, you're telling me, since this is a diameter, this little half circle is 180? I got you. I think we're killing it. I feel you on that. 180. We got you. Now, if this is 180, stick with me. We have an inscribed angle situation, do we not? Here's the arc. Here's the angle. If it gives you the arc, you divide by 2 to find the angle. So if this is 180, what's 180 divided by 2? 90 degrees. So this is going to be 90 degrees. Huh. Okay. Cool. Well, guys, check it out now. In our triangle, we now know all 3 sides of our triangle. Huh. Well, according to what we learned on the last page, what do all of the angles in an inscribed angle add up to be? 180, obviously. So we would do x plus 4x plus 90. All that's going to equal 180 because, duh, all the angles in a triangle always add up to 180. X plus 4x, 5x, plus 90 equals 180. Okay, I'm just going to kind of continue to solve this. 90, 5x equals 90. I believe your answer here is going to be x equals 18. X equals 18. Okay. So we had a missing side. Okay. Now, here on this one, we're still missing a few things. So I've actually made the decision to go ahead and skip this one for now. It doesn't come up in your homework, and I don't think it's worth our time right now. But I will go over a couple of the advanced problems. Okay. The advanced problems, you could pause it. Like if you're in a regular class right now, you could pause it. You don't really need these, but if you want to keep learning, you can do that. This is the advanced. So it's very simple. If this is my arc, the inscribed angle is this. So we simply use our equation. Arc equals 2 times angle. Let's solve for x here. It didn't have instructions. Solve for x. Okay? So we're going to have arc equals 2 times angle. The arc is 11x minus 5 equals 2 times 4x plus 14. And then we solve that. Okay, that's all we do. Equals 8x plus 28. 11x minus 5. Again, this is all algebra at this point, so I'm kind of going fast. Subtract 8x on both sides. 3x minus 5 equals 28. Divide plus 5. 3x equals 33. I know I'm getting kind of running out of room. X should equal 11 here, I believe. Okay. Arc, if it helps to maybe highlight, arc equals 2 times the angle. Okay? All right, what about this one? Similar idea. We have an inscribed angle. Okay? We have our arc. But oh no, we don't know what our arc is. Have no fear. We got this. Okay? Here's something we can do. If we know that arc always equals 2 times the angle, What's our angle? 6x minus 6. So couldn't we say that this arc is technically 2 times 6x minus 6? All right, let's just put that there for a second. 2 times the angle. Interesting. We're just going to put that there. Now what can we do? Well, we know this arc, we know this arc, we know this arc. All three of them are going to add up to be 360 because it's the entire circle. So I can do 2 times 6x minus 6, that's one arc, plus 18x minus 7, plus 18x minus 5. All that's going to equal 360. Okay, there's a few different ways we could have solved this problem, but this is the one I'm rolling with. Okay, I'm just going to solve it. So I first got to distribute 12x minus 12 plus 18x minus 7 plus 18x minus 5 equals 360. Let's keep going. 12 plus 18 plus 18. Let's see what that is. (48x). Negative 12 plus negative 7 plus negative 5. Whoops. I believe that is negative 24 equals 360 plus 24. 48x equals 384. X equals 8. Again, guys, those are just advanced. They're really just advanced because they've got a lot of algebra. Other than that, you can totally do those. So you're going to work on 9.3 notes. I know it's a lot of problems, but you can totally do this. You got this. Arc equals 2 times angle. That's what you got to know. Have a great day.